Hello, so here is the original problem, okay, right here. So it wants you to simplify that on that sample page. So we're going to factor. So you had this part right. This part was incorrect. In fact, the common factor is x, not 2x, so it's x minus 2. All right, and then I've got to find a common denominator, so I have a factor of x here, so I need to multiply the top and bottom by x. Then over here, I have a x minus 2 shared, but I need to multiply x plus 2 to both sides, so that's going to give me that. So that gives me all of that under one denominator, that. So negative 2x is here, and then plus, since that's all under one denominator, work that part out, and I get x squared plus 2x minus x, and then minus 2, and that's just from that. All right, so that negative 2x plus 2x cancels out. It leaves me with x squared minus x minus 2 all over that. All right, x squared minus x minus 2, and then I factor that out, and that gives me x minus 2 x plus 1 over x plus 2 x minus 2. So here, to find the restrictions, by the way, restrictions or the asymptotes, x equals 0. In other words, it can't touch it at x equals 0. There is no 0 comma anything. There's not going to be any negative 2 comma anything, and there's not going to be any 2 comma anything, all right? Because 2 gives me a 0 on the denominator. So 0, negative 2, 2 are like the restrictions. It's also the points of discontinuity, which is step 4 there. So, all right, let me see here. So from here, that's that. So now that cancels out right here, but we still got to use negative 1 and for restrictions and so on and so forth. See, x plus 1. Oh, I don't know why I canceled the x plus 1. I think I just made a mistake there. Hold on. X minus 2, x plus 1. Oh, the x minus 2's cancel out. My bad. And so I had the wrong thing. So rewrite that. Sorry. So the x minus 2, the x plus 1's don't cancel out. The x minus 2, actually none of that cancels. None of that cancels. Sorry. So it's actually just that. Sorry about that. So it's actually just that x minus 2, x plus 1, x plus 2, x plus 1. These things can get into your head because it's all over the place. I'm double checking. For some reason I thought I could cancel on it. So I'm going to pause it just to double check myself. Yeah, so those x minus 2's do cancel out right there. That leaves you with x plus 1 over x plus 2. But again, when you're doing the asymptotes and stuff, you still can't ignore those old factors. If you look at the graph, you'll see, and you look at the table on a graphing calculator, you'll see 2 is an asymptote, x equal 2. Nothing touches it there. But here's your result at the end, okay? I think I got that right now. X minus 2 cancels out, yeah. So it's been a long day for me and myself. So that's kind of like step 1 there, it looks like. Where step 1 you had to factor the numerator and denominator. So we did that. To find the x-intercepts by setting the numerator equal to 0. Again, you kind of have to actually go back to setting these equal to 0 up there. So if you kind of look, there is no x equals 0. So there is, with x equals numerator 0. So, I'm sorry. So you set them equal to 0. So x minus 2, x plus 1 is what factors on top. The 2 won't work because it's a restriction, but negative 1 is a one that will actually work. Okay, is one that will actually work there, because negative 1 will give you 0 there, The 2 won't work just because it's also a restriction. So -1 will give me a for step 2. All right, for I'm losing my mind here. Finding the x-intercept, right? Because you're trying to set it equals 0. Find when y is 0, find x. So to find the y-intercept, you plug in 0 for x. All right, and in this case, there is no y-intercept because 0 is a restriction. So for to have a y-intercept, there has to be a 0 comma something. Well, there is no 0 comma anything. It's an actual asymptote, so there is no y-intercept. Step 5, you're supposed to, I think, on that one, find any holes, blah, 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 points, discontinuity. Okay, so number 5 is right here. So yes, x plus 1 factors cancel, but we use it for finding asymptotes, intercepts, etc. So I'll show you it's not x plus 1 that cancels, it's the x minus 2, excuse me. Sorry, the x minus 2 cancels, factors cancel, but we still use that to find those things there. So it can, I'm not really finding holes. Seems like an awful lot to think about. Points of discontinuity we've already talked about. So number 6 is the vertical asymptotes. That's just the restrictions on the denominator. So we've already, those are these equations here, x equals 0. It'll approach those points. It will approach x equal 2 and approach x equal -2. Number 7, you're trying to find out how to find the horizontal. If you look at step 7, it tells you. So if you look at the degree of the numerator, it's 2. The degree of the denominator is 3. So whenever the degree of the numerator is less than the degree of the denominator, you always get the horizontal asymptote is y equals 0. And you'll look, there is no. It approaches the x-axis, which that's the equation of the line y equals 0, but it never touches it. So y equals 0 is an asymptote. Number 8, the domain is really all real numbers, except 0, 2, and -2, which are the restrictions. Yep, that's a lot. A lot of it's kind of repetitive. So I'm not a big fan of, I guess, all that, but it works, and it makes you really think about it. So hopefully that helps a little bit, and hopefully you followed my factoring on the thing. I kind of messed up. Realized I had the wrong thing because sometimes you miscopy stuff and you switch a sign and you don't realize what you just did. So, but I do have the right answer at the very end. I got it right. So there you go.